In this video, I'll be installing and testing the mass airflow meter conversion kit for the 8-valve Naturally Aspirated 944s by Lindsey Racing. Earlier this year, I picked up this aftermarket MAF tune kit that replaces the heavily restrictive OEM airflow meter, or AFM, that comes standard with these cars, and there's a video on the channel that describes the differences between a MAF sensor and the factory AFM if you're interested. In preparation for the installation, I recently had the car dyno tested so the before and after results could be compared. This baseline test was conducted on a DynoJet 248H and returned values of 132 max horsepower at the wheels and 138 foot-pounds of torque, which is about what I would expect from this later 944. This US specification 1988 model year featured a slightly higher compression ratio due to a change in the pistons that increased the rated output to about 158 brake horsepower. And if we factor in a power loss of about 15% from the drivetrain, the numbers line up pretty well. The air-fuel ratio shifted a little lean after 5,000 RPM, which I'm guessing is a result of the aging and now uncalibrated airflow meter, but we'll see how that presents after the installation. So with that out of the way, let's get into the modification and see how the performance stacks up against the post-installation results. The MAF conversion kit can generally be installed in under a couple hours and doesn't require any specialized tools, but there are a few requirements to consider. The first of which is the car's DME computer. The new 28-pin performance chip that comes with the kit is a direct fit to the DMEs found in the 88 and 89 model year 944s, but the 24-pin DMEs found in years 85.5 through 87 will require a conversion to a 28-pin configuration, so it's a good idea to confirm your existing setup before you begin. Additionally, the MAF sensor requires a 12-volt switched power source to operate correctly, and I'll talk through a few of the different ways that can be achieved, but aside from that, the rest of the kit is plug and play in terms of installing the new intake tube between the J-boot and the air filter housing, as well as connecting the wiring harness adapter to the factory AFM connector. Since we'll be working with the car's electrical system, we'll start by disconnecting the negative terminal on the battery, and then the DME computer can be safely removed from the car. To access it, all we need to do is pull the carpet back on the passenger footwell area, remove the screws securing the wooden kick panel, and behind it we'll find the DME computer attached to a metal bracket. At this point, the two screws at the bottom and the two plastic screws up top can be removed and the assembly pulled out a bit. Then the DME connector retaining clip can be pushed to the right while pushing up on the DME connector to disconnect the wiring harness. And finally, the screws holding the DME to the support bracket can be removed and the DME computer pulled from the car. With the DME removed, we'll be opening it up to install the performance chip in place of the factory analog to digital converter chip, and to do so, there are 10 metal tabs on the back of the housing that need to be gently lifted and straightened using a flathead screwdriver. Prior to removing the cover, it's a good idea to apply an ESD wrist strap to protect the internal components from any electrostatic discharge. With the cover removed, we can see the two circuit boards connected at the center by some ribbon cables. There are some connector posts at the base of the boards that snap together, and those will need to be separated by pushing the upper board up slightly on both sides. Next, the two holding tabs at the top can be gently pushed down while pulling back on the upper board to reveal the components inside, and with everything exposed, we can see the factory ADC chip that needs to be removed. So just carefully place a plastic spudger or a flathead screwdriver beneath the base of the chip and twist it from side to side to work the chip out of the socket, going back and forth on the two ends of the chip to ensure that it's lifted as evenly as possible. And at this point, the new chip and chipboard set can be installed into the socket with the top of the lettering on the chip facing towards the closest outside edge of the circuit board. Make sure the chip and chipboard are fully seated in the chip socket, and once it looks even on all sides, the DME can be reassembled and closed up in the reversed order of disassembly, and the unit reinstalled in the car. Now that the performance chip has been installed, we can begin swapping out the components in the engine bay and wiring up the new MAF sensor. We'll be fully removing the factory AFM here, which is attached by four 10mm bolts on the inside of the air filter housing. So go ahead and remove the 5 Phillips head screws securing the housing cover, and disconnect the breather hose running to the belt covers if you haven't already capped off those connections. Lift the cover off the housing, remove the air filter, and then loosen and remove the bolts connected to the AFM. On the other side, loosen the clamp holding the J-boot in place and separate the two parts. Finally, disconnect the wiring harness from the AFM, and then the unit can be set aside. The new aluminum intake tube and MAF sensor can now be installed in place of the factory AFM. We'll want to ensure that the mating surfaces are clean here and that the paper gasket is replaced if the original one is cracked or brittle. And with the gasket in place, the four 10mm bolts can be reinstalled and torqued to a value of 7.5 foot-pounds. Again, on the other side, the ring clamp can be tightened down so that the J-boot is secured to the intake tube, and then the air filter can be reinstalled, along with the housing cover and the breather hose. With the new parts installed and the hardware tightened down, the wiring harness adapter can be connected to the MAF sensor and the factory AFM wiring connector. The final step of the installation involves routing the 12-volt power wire that splits off and requires connection to a switched power source for the MAF sensor to function. The provided instructions recommend using the positive terminal on the ignition coil to achieve this, so the red wire would need to be routed across the engine bay and connected up on the other side. A potential path could follow the wiring for the oil pressure sending unit that passes over the water pump and then over to the coil, but there are a couple things to consider with that approach. One, the ignition coil circuit isn't fuse protected, and two, the wire would end up just floating across this gap between the engine and the frame rail where the coil sits. To solve for this, an inline blade fuse could be used to protect the MAF sensor, and an alternate routing path could be considered for the wiring. That said, if I really wanted to use the coil circuit, a cleaner look might be achieved by following the path of the main wiring harness that runs behind the front bumper and over to the passenger side. But at any rate, I'm more inclined to tap into this now unused vehicle diagnostic port back here by the firewall on the driver's side, as others have done in the past. Some people have reported lower voltage readings than expected from these test port terminals, so we'll need to conduct some tests to confirm 12 volts on the circuit when the ignition switch is turned on. Prior to starting the installation, I went ahead and took some voltage readings around the engine bay, and I was getting about 12.3 volts directly from the battery, right around 12 volts from the ignition coil circuit. And when I tested the two switch terminals on the diagnostic port, the meter was reading about 4.8 volts from one terminal and 11.2 volts from the other. Since the MAF sensor requires at least 12 volts to function properly, I wanted to see if the voltage at that last terminal would increase after the car was running, and it actually jumped up to about 13.3 volts after starting the car. So provided that the car will start with the slightly lower voltage on that terminal, the running voltage is more than enough to power the MAF, and I'm going to move forward with that option and test it out. This is a later car, so it'll be fairly easy to tap into a relay at the central electrical panel as needed, but this test port is a pretty clean and direct path to get the MAF wired up. A quick note on these test ports is there are some differences across the earlier and later cars. When you look at the ports, you'll find 5 terminal holes recessed inside the rubber plug. One is set off by itself, which is a positive battery connection on the early cars, and a ground connection on the later cars. And then there are 4 others arranged in a semicircle on the other side of the plug. Moving in a clockwise direction from that first terminal, the very next connection point is the switched 12-volt power source on the early cars, but that was eliminated on the later cars, and the 12-volt switch source was moved to the second terminal hole from the central terminal. I've seen information indicating that the diagnostic port resides on fuse number 17 on the electrical panel, but I did not find that to be the case on this later car, and in fact, after removing all the blade fuses at the panel, the diagnostic ports were still receiving power. So I've got a 5 amp inline fuse that I'll tie into the power lead while getting everything connected, and that will provide some protection for the MAF sensor. I went ahead and routed the power wire along the pathway of the small vacuum line for fuel ventilation control valve number 2, and wrapped it in some 1/8 inch split wire loom for a little abrasion resistance, and then locked it in place with some zip ties. I tapped into the diagnostic terminal using a bullet connector, and ran the wire down below the plug to the fuse holder, which is positioned just behind it for easy access. With the 12-volt power wire connected, we can now reconnect the negative lead on the battery and prepare to start the engine and inspect for normal operation. In some situations, the idle speed will need to be adjusted after installation due to the MAF setup being less restrictive than the factory AFM, and if that's the case, it can be done using the idle set screw on the side of the throttle body. So let's go ahead and start the car and see how it runs. As you can see with the initial test run, the engine is turning over but is failing to start. While the engine is cranking, the voltage on the circuit is dropping to the point where it's just not enough to power the MAF for ignition. I believe the 12-volt test terminal is on the same circuit as the idle control valve, and my guess is it's just not enough to power both the valve and the MAF on the same circuit. So I'm going to tap directly into the fuse panel and see if I can get a better result. So I've got the power wire temporarily jumpered to pin 86 on the relay for the fresh air blower that sits at position G1 on the fuse panel. as that was the next closest switch to 12-volt power source I could find. So let's try again and see if we can get it running. Well, it looks like that did the trick. The engine started right up and didn't present any idle issues, but there was some hesitation on the initial throttle tip-in. It seems like it's running just a little lean with all the free-flowing air, but luckily there are some fuel mixture settings designed into the mapping for the MAF kit, and those are controlled using the fuel quality switch, or FQS, on the DME computer. The FQS is a small rotary switch located at the bottom corner of the DME housing, and you may have to first remove a plug to gain access. The dial features a triangular socket, so you can either use a carefully inserted 2.5mm Allen key or grind down an old screwdriver or Allen wrench into a triangular shape. When making adjustments, if you rotate the switch all the way counterclockwise until it stops, that's considered position 0. From here, the first click in a clockwise direction is position 1, the next click is position 2, and so on. With the new performance chip installed in the DME, the values are now different from the factory settings, and we have the option to change the fuel mixture percent at a few intervals between -9% and +12%. After a bit of trial and error, I was able to eliminate the throttle hesitation by setting the switch to position 5, which is +9% to the fuel mix. So I think it's time to take the car out and see how it drives. After getting the car out and opening it up a bit, it feels like it's running pretty strong with no irregularities in the performance. The throttle response is improved over the factory AFM, and there's a noticeable surge in power between 3,000 and 5,000 RPM, but I'm looking forward to putting it back on the dyno with the wideband O2 to see how well it's dialed in and make any changes from there. Well, I was able to put the car back on the dyno for some tuning runs, and based upon the results, the +9% to the fuel mix was running a little rich. So I dialed it back to +6% and then +3% for analysis, and the best performance ended up coming from the +3% position. The performance gains at this setting resulted in 138.4 horsepower, up from 132.1 over the factory AFM, which is an increase of 4.8%. The torque value hit 141.6, up from 138.7 over the factory AFM, which is an increase of 2.1%. Notably, the fuel delivery was much more evenly applied in the upper RPM range with the MAF, where the AFM had previously gone lean after about 5,000 RPM, so I think that confirms the inconsistency in AFM calibration and functionality as those units age, and it's nice to see the actual gains on paper from the MAF conversion. Outside of the numbers, the MAF setup definitely transforms the driving experience, and while it certainly doesn't make the car substantially faster than it was before, it's much more in the accessibility of the power and just being able to use it how you want to. When you get on the throttle with the MAF, the car is much more responsive. It makes it more enjoyable for spirited driving because you're not waiting 3-4 seconds for the AFM's flapper barn door to open up. So that for me is the biggest gain. It modernizes the driving experience, makes it more fun to drive, and has some added reliability as well. As far as the wiring goes, I've got the temporary jumper line replaced with a wire routed off to the side and tapped into the pin on the fresh air blower relay so that it can be reinstalled. And it's connected to the blade fuse with some waterproof heat shrink connectors. So this will be functional enough to test the MAF a bit more, and I'll probably do a cleaner pass-through on the firewall if everything remains stable, either coming up below the panel and splicing into a line, or maybe drilling a hole near the top of the metal fuse box and using a single wire rubber grommet to pass it through, just so the installation is resistant to the elements and has a cleaner finished look. And that concludes the installation and review for Lindsey Racing's NA-Tune MAF conversion kit. I'll note for those interested that I'm currently running the factory exhaust with the catalytic converter installed on this car, along with the early cast iron headers. Outside of a throttle response cam, some 944 turbo valve springs, and a short shifter, which are modifications that don't really add power anyway, the car is essentially stock. So I think there's definitely potential to make some additional gains when coupling the MAF conversion with some other mods. Overall, the product is fairly easy to install, it's plug and play for the most part, and requires minimal trial and error to make adjustments to the fuel mix. The tunability does stop there, however. It's just one set map that's preloaded on the chip, so if you're looking for something with more customization, this probably isn't the solution you're looking for. That said, if you've already got a failing AFM that you're planning to replace, or you're interested in some minor gains while enhancing the reliability and driving experience on your 944, the MAF kit is worth a look.